So in this question, like two cars A and B are traveling in the same direction with velocity V and VV. When the car A is at a distance S behind the car B, then the driver of car A apply the brake, producing uniform retardation, and there is no collision. When? So there are two cars. You can consider this is the car A and this is car B. They are traveling with velocity VA. Let us suppose like this. Since VA is more than VB, so it is confirmed they will collide. When the car is at distance S, what they are saying? When the car, this car and this car is at a distance S, when a car, this is car A, okay? When a car A is at a distance S behind car B, then the driver of car A apply the brake, producing uniform retardation, okay? And there will be no collision. Clear? So he is applying the brake and there is no collision. So condition is there. Collision will not be there only when the velocity of car A and velocity of car B is equal. Yeah. Meaning is that let us understand with the help of one example. For example, this is a car A. It is moving with the 10 meter per second and it is moving with 5 meter per second. So it is confirmed this will collide with this car. But we want like both the cars should not collide. Then this driver of the car is should apply the brake in such a way that its velocity after applying the brake velocity of car A must be equal to the velocity of car B. Meaning is that okay. So what they are saying, when the car A is at a distance S behind the car B, then the driver is applying the brake, producing uniform retardation. There will be no collision. Clear? So when is up these two cars, this is moving 10 meter per second, this is moving with 5 meter per second. So it is confirmed collision will be there. Now we want like there should not be a collision. So when the driver of car A is at a distance of S behind car B, then this driver is applying the brake. Because of this brake, this car velocity will decrease, and finally he should apply the brake in such a way that there should be common velocity. They should move with a common velocity. Then only there is no collision. Okay. Collision will not be there when the velocity of two objects are equal. Clear? He should apply at least up to this. Minimum. Maximum. Okay. He should decrease the velocity from 10 to 5. Let us suppose. In our case, what is the question? This is the car. Okay. This is a car A and car B. Okay. Car B. It is moving with velocity VA. It is moving with velocity VV. Okay. Since VA is more than VA, as per the information, VA is more than VB, it is confirmed like they will collide. When the car A is at a distance of S behind car B. Okay. Now moving to the condition. When car A is at a distance of how much? S from car B. Okay. like this. Clear? So what they are saying, the driver of car A apply the brake, producing uniform retardation, so that there will be no collision. Clear? So he is applying the brake. Finally, his velocity, both the velocity should be equal. He is applying the brake, and after that, the velocity of this car, let us suppose u, and velocity of this car must be equal. Then only there is no collision. Then condition, let us suppose it is almost less than s separation. Clear? So how much it travel? Let us suppose d. Okay. So if I take the frame, if I take a frame of reference from the car B, with respect to car, observer is on the car B. Let us suppose I take my observer here. Okay. So velocity of car A, initial velocity. Velocity of car A with respect to B. It is VA minus VB initially. After, at this instant, when I am saying velocity of car A with respect to car B, observer is here. Okay, at car B. It's a initial. Final is we don't want collision to happen. So finally, you can check final velocity. VA, velocity of car A with respect to car B. You can check both are moving the same velocity. So it is relative velocity is 0. And it is the condition like there is no collision. There is no collision. Clear? Okay. So he should apply the brake in such a way it will travel this distance d and acquire the common velocity as car B. Meaning is that. So we can apply v square is equal to u square plus 2as. So what is v? Final velocity is 0. This is I'm applying for car on car A because I have taken everything I am taking with respect to car B. Clear? Initial velocity, that is VA minus VB whole square plus 2. Acceleration how much? What is the acceleration? Tell me, what is the answer? Tell me the answer. What is the acceleration? If you look at carefully, what is the acceleration of car A? It is moving with, it is applying the retardation, uniform retardation. Clear? Okay. So A will be what? A relative. Clear? So what is A relative? You can check acceleration of car A with respect to car B. AA minus AG. AB with respect to ground, with respect to ground. So it is minus A. Acceleration of car B with respect to it is moving with a constant velocity because we are not applying any brake. There is no brake applied in car B. So there is no acceleration. It is moving with a constant velocity. So acceleration of car A with respect to car B will be minus A. So you can write here it is minus A, and how much this car travel? D. You can check. Okay. So 0, 1 minute. It is D. So what is the distance? Like how much distance it travel? Equal to VA minus VB whole square divided by 2A. So condition is there. This D. What is the D? This D must be. What is the condition like? Condition is there. He should apply the brake in such a way D should be less than S only. For example, this car A, okay, and this is car B, okay. It is moving with, for example, u velocity, and it will apply the brake. It will apply the brake, and if the car, one minute, clear. If this car A is applying the brake and it is gaining the velocity u, the car A is getting the velocity u, common velocity, when this car A is here, clear. When the car is here, so how much distance travel? This much. Almost, if you ask me like how much, it is very, very closer to S. Okay. So our objective is these two should not collide. So this D, whatever distance you have calculated, it should be less than the separation, initial separation. Clear? Less than or equal. Okay. This car A, car B. Separation, what is the condition? S. When car A is S meter behind car B, then this car A, the driver of the car A will apply the retardation, will apply the brake. He will apply the brake in such a way, either he should gain the velocity at this point, at this point, at this point, means he will travel, the car A will travel the distance D. It should be less than or equal to S. This car A either travel S or it should be less than S. Then there is no collision. These two cars should not touch each other. Meaning is that clear? Here collision is clear to you. Okay. So what is D in our case? VA minus VB whole square. VA minus VB whole square divided by 2A. This is the answer. So what they are asking in the question? This is the condition actually they are asking. Clear? When? When? They are asking when. Okay. So you should write when S is what? Answer is when S is greater than equal to VA minus VB whole square by 2A. Is it clear? Okay. Thank you so much.